Assalamualaikum warahmatullahi wabarakatuh dan selamat sejahtera. Welcome to the new chapter 2, Solid Gas Interface. This chapter, we discuss about the adsorption of gas on solid surface, which then can be used to characterize the solid, such as surface area, porosity and pore volume. Okay, this is video part 1. In this video, we are going to discuss about the two types of adsorption on solid surface, physisorption and chemisorption. First of all, let's define the solid. Solid is a state of matter where the molecules are closely packed together in ordered arrangement. The molecules are rigid, which means not free to move and have least amount of kinetics energy. Okay, powder is a type of solid which comprise of discrete particles. Meanwhile, the fine powder defined as substance having the particle size less than 1 micrometer. There are several terms related to the gas-solid adsorption we have to familiarize with. First, adsorption. Adsorption is a process when gas is brought from the bulk phase to the surface of solid. The gas then attached to the surface of the solid, forming a layer of adsorption. Okay, desorption is a reversible process of adsorption where gas is released from the surface of the solid to the bulk again. Okay, adsorbate is a gas molecule that has adsorbed at the surface of the solid, while adsorptive is the gas molecule in the bulk phase. Adsorbent is a solid substance which is able to adsorb the gas molecule. There are two terms related to the adsorption, which are adsorption and absorption, AD and AB. Okay, adsorption is the enrichment of gas molecule onto a surface of solid substance. Meanwhile, absorption is the penetration of a substance into the bulk of solid. Okay, kalau dalam bahasa Melayu, adsorption adalah penjerapan, absorption adalah penyerapan. In reality, both processes are very difficult to distinguish. But in our case, we assume that the gas molecule just adsorb on the surface without penetrate into the solid substance. The adsorption of gas molecule on solid surface can occur via two types of forces, physical and chemical forces. Physical adsorption, also known as physisorption, and the chemical adsorption is known as chemisorption. General difference between physisorption and chemisorption. Okay, physisorption, the attachment of molecule to the surface is by weak molecular force such as van der Waals force. There are no permanent bond formed between the gas molecule with the solid surface. The gas molecule is not chemically modified, which means there are no bond broken or formed. In other hand, chemisorption involves attachment of molecule via strong covalent bonding. That means in this case, the gas molecule is modified where there are bond broken and formation of new bonding. In detail, we can differentiate between chemisorption and physisorption based on the following criteria. First, the types of bonding. Chemisorption involves short-range bonding such as covalent bonding. For the adsorption to occur, the bond between the gas molecule must be broken first before a new bonding is formed between the gas and the solid surface. Physisorption involves a long-range bonding such as van der Waals force, hydrogen bonding, dipolar interaction and dispersion force. These bonding are weak compared to the covalent bonding, and no bond are broken or formed for the adsorption to occur. Adsorption enthalpy or delta H of adsorption. First, let's see the interaction energy curve for chemisorption and physisorption here. Assume that at distance equals to 0 is the solid surface. The orange curve is the chemisorption and the pink curve is the physisorption. Okay, both curves have a minimum well which represent the adsorption of the molecule on the surface of the solid. The distance of the minimum well from the y-axis represent the types of bonding between the gas molecule and the solid surface. If you can see here, chemisorption absorb at a shorter distance than the physisorption. That means chemisorption involve short-range bonding, while physisorption involve long-range bonding, as discussed in the previous slide. Okay, the depth of the well represent the adsorption enthalpy or delta H adsorption. For chemisorption, the delta H has a wide range, typically from -40 to -500 kJ per mole, while for physisorption, the delta H typically from -10 to -40 kJ per mole. Delta H for physisorption is related to the factors such as the gas molecular mass and polarity. Nature of adsorption. For chemisorption, it is often dissociative. Dissociative means the bond between the gas molecule must first be stretched and weakened, then broken up before forming a new bond with the solid surface, as shown in this figure. The bond between the hydrogen atoms in hydrogen molecule is stretched and weakened, which then broken up to form a new bond with the solid surface. Okay, the same here for the oxygen, and the process may be irreversible. For physisorption, it is associative, which means the adsorption can occur without bond breaking and bond forming, as shown here. The adsorption of H2S on a metal surface, and the process is reversible. This means that the gas molecule can be released back to the bulk phase when increase the temperature above its condensation point. Okay, the next, kinetics of adsorption. For chemisorption, it depends on the temperature of the system as it involves high activation energy. So energy should be supplied to the system to overcome the activation energy. For physisorption, the process is fast as it is non-activated process. But the rate of adsorption is controlled by the diffusion, which means how easy to bring the gas molecule from the bulk to the surface of the solid. Temperature range for the adsorption to occur. For chemisorption, the adsorption can occur over a wide range of temperature, but there is an optimum temperature where the adsorption will be effective. As shown in this figure, X over M is the amount of gas absorbed onto the surface of the solid. If in the case of chemisorption, X over M increase initially with a rise in temperature until the optimum point, but then decrease with further increase the temperature. The increase in temperature at first provide the activation energy needed for chemisorption. As we know, chemisorption involves broken and formation of new bond. So increase the temperature at first provide the energy needed to break the bond between the gas molecules and form new bond with the solid surface. However, further rise in temperature result in a decrease of adsorption. This is because adsorption is an exothermic process. Hence, increase in temperature will eventually not favor the adsorption. For physisorption, the adsorption occur near or below the condensation point of the gas, and the adsorption decrease with increase in temperature as shown in this figure. This is because with increase in temperature, the adsorbed molecule have enough energy to overcome the weak van der Waals force of attraction. And the last, saturation update. For chemisorption, it is limited to only a single layer or monolayer because covalent bond should be formed between the gas molecule and the solid surface. For physisorption, the adsorption can be multi-layer as shown in this figure. Okay, this exercise is related to this topic, so please answer and submit in e-learning. Okay, that's all for now. Thank you.